I chose this career path because I found an interest in technology. Technology is always advancing, and so there's a huge need for people who are interested in wanting to be a part of that. I'm an electrical engineer, but my title here on base is an electronics engineer, and I focus on software maintenance. We actually write the test cases, so I'm basing all of my information based off of requirements that come from our customer.
Those requirements grow into test scripts, which we use on this station. We press buttons, we simulate pressing buttons, and it's really essential to make sure that we break that code. And what I mean by breaking that code is we push the limits of that code. I'm a test engineer, and I create a test procedure. And depending on what I'm testing, for example, I work on the flight sim. So if we have a requirement that the aircraft has to fly at 5,000 feet, I have to take that requirement and I have to simulate that and make sure that our aircraft can actually fly at 5,000 feet. We have a huge database of just GPS information of what the world looks like. We get that data and we replicate that in a flight sim. So we're able to replicate the world around us. My goal is to make sure that when you're flying from point A to point B, that you have the speed correct, the altitude correct, the wind velocity correct, the accelerations correct, all the ailerons on the aircraft correct. It's very involved, so I need to make sure that the aircraft and the flight sim are perfectly aligned.
We have test points that are on the aircraft that let the flight engineer know if everything is running okay. That information is being stored on a disk and transferred to us. And what we do is we analyze that information and we look at the flight and make sure there are no issues or improvements. I bring it into the lab and I run through them and make sure that the software is doing exactly what the requirement says that it's supposed to do. So I make note of anything and everything that goes well or things that go wrong, so I pass or fail. So if we find a bug, we analyze it first to make sure what we found is actually a bug. We do an analysis, we go on into testing, and then after that, we actually fix it. And how we fix it is we go into the code, we look for kind of triggers that cause the bug to happen. Having to look through lines and lines and lines of code and finding one single problem, which could be a semicolon or a spelling error, to figure that out was challenging to me.
My dad was an engineer. He actually worked on the platform back in the 80s, so right when it was starting. And he got me into it and made me all excited about it. And that's essentially why I'm doing what I am doing. When you go into a STEM career, there is endless possibilities of a career. You can have a job in anything because every single job out there is in some kind of STEM outlook.
It's really important for people to understand that the things that we learn in school for engineering, math, technology, it influences our future. If we don't have people who have those minds that think outside the box, then we have nothing. Math is fun, and seeing how you can use math to build anything. You can use technology to create more technology, and you being a part of that.
I love my job because of the people that I work with. It is a team environment. I just love learning and I love solving issues. The people best suited for this career are problem solvers. People who love math, love science, love technology, love engineering, people who are into software, electronics. This is perfect for you.
My name's Dave Schlafman. I'm the co-founder of Cloud Kid Studios, and we make games for kids.
Which activity uses the most energy?
We're a very collaborative studio, so whenever we have to come up with a game idea, We meet with our animation director, our producer, and we say, what can we create? What are we gonna have a lot of fun producing? We get this great idea, and it has to teach something. So we're not teachers, although we think of ourselves as teachers, so we go to the pros.
If you want to go down to the younger ages.
Our last project for PBS, we worked with a math specialist, and she was so helpful in really explaining to us how kids learn and what types of challenges kids have when they learn through games and what can they understand. Once we have a wireframe, we have to write a script so we know what all the characters are gonna say. Then we have programming that actually starts to build the actual game. And then we also have all the artwork. What do the backgrounds look like? I actually like all the shadows on the character. There are lots of things that are happening at once, but sometimes you can't start animation until the voice recording's done. And the script has to be done before the voice recording. So a producer really fills that role of how to take all those different parts and make sure they're all happening at the same time. A programmer will start with the wireframe and they say, okay, I know that this character needs to do X, Y, or Z, and then they write code so that that character can do that. I like what you guys did with the levels. We try to use real life, real world situations. And the more math games that we've been creating, what we realize is math is everywhere. But math is more than numbers. It's also problem solving. It's exactly what a game designer does, is how do you bring all these different things together and solve a problem? Art is really a team sport, you know. Programmers and game designers and writers and artists and animators, and I think that's what I love about waking up and coming to work every day, is just getting to work with such an amazing team of people.
What I put my effort toward currently as an engineer is a powered rope climbing device that's useful for search and rescue operations. It allows a person to much more quickly and easily execute high-angle rescue scenarios, such as what firefighters might perform. My name is Nate Ball, and I'm a mechanical engineer. My job as an engineer is to use what I know about the world and what I know about how things work to solve problems to help people.
As a mechanical engineer, Nate pushes technology to its limits by using his knowledge of motion and energy to develop all sorts of mechanical devices, including a new vaccine delivery system called the VacPack.
There are about 4.3 million deaths that are caused every year by vaccine-preventable diseases. And a major challenge in getting vaccines to the appropriate places in third world countries is being able to keep them at the right temperature. Vaccines have to stay, in general, at about 4 degrees Celsius in order to stay usable. And to get vaccines at that temperature into really rural areas with spotty electrical power is a big challenge. This device here is a portable vaccine refrigeration backpack. It's like a refrigerator you wear on your back that allows you to take up to 1,200 vaccine doses into a rural area that doesn't have normal power. So in a situation where you've got major infrastructure devastation, like in a huge earthquake in a third world country, a device like this has a great potential to make a big difference, because you can take massive doses of antibiotics and needed medicines into rural areas that have no power in order to be able to deliver the needed medical help.
Nate spends much of his time refining his designs and building models and prototypes to get products ready for manufacturing.
What we're looking at here is a 3D model of an early version of the backpack that's actually created inside the computer. So in engineering, if you're building a complicated system, it's very useful to build a model like this in order to visualize how all the parts will actually attach together. You guys need to...
Nate shares his passion for engineering by mentoring others. He even hosts a TV show for PBS called Design Squad.
So on the show, I get to mentor a couple of teams of young engineers and introduce challenges to them as week to week they split into teams and hear from a client, kind of like real engineers do. And the client says, hey, design squads, I need you to build this for me. I need you to solve this problem.
I want you to build me the fastest dragster possible.
And the kids on the show actually go out and do it.
All right, so we got our forks up in front.
We're gonna have a 6-foot coil of rebar like a tornado.
When he's not inspiring future engineers, Nate can often be found helping athletes reach new heights.
I actually coach some of the MIT pole vaulters here. And I'm also a pole vaulter myself, and I have been since about 6th grade.
Go, Emily.
Robins Air Force Base is advancing STEM fields because we're on the cutting edge of sensor technology and software development. I'm a lead engineer of an electronic warfare system. It's called the ALQ-213, but it's an electronic warfare management system. And what it does is take inputs from different sensors and things on the aircraft and makes a cohesive picture for a pilot so they can assess what's going on outside the aircraft. So we work with pilots to figure out what it is they want the box to do. So then I take those requirements and work with software developers and hardware engineers to translate that into actual stuff so that the box does what the users want it to do.
I'm a systems engineer. The electronic warfare avionics is very interesting. It provides me the opportunity to not only specialize on one specific system, say as the F-15 or F-16 platform itself, but also gives me the opportunity to cross-cut into multiple platforms here in the Department of Defense. So I'm not relegated to only just one aircraft. Tactical data link systems that I currently work with here at Warner Robins are the MIDS multifunctional information distribution system and joint tactical radio system, as well as the roll-on beyond line of sight enhancement system.
The tactical data link systems, or Link 16, are placed on aircrafts and vehicles to improve communication and give military personnel an accurate depiction of their surroundings.
TDL is the opportunity to provide not only a visual sight picture to pilots, as well as combat commanders to be able to see where their enemies are located, where their friendlies are located, as well as also provides an opportunity for pilots to actually acquire targets and to be able to identify those targets and to say, hey, that I'm responsible for this specific target. We work closely with the Air Combat Command, but also we work with those users to make sure that we are doing the right thing in terms of the acquisition process. The systems that I actually work on actually affect the lives of those men and women and the DoD and then the United States Air Force in the actual working environment. How can we effectively be a next generation Air Force if we're not communicating with one another, if we don't know what the left or the right hand is doing? So one of the things that Link 16 provides is the opportunity for you to actually know what your co-pilots are doing, what your flight crew is doing, where your friendlies are, and how to support them in the best way possible to be able to communicate effectively.
A typical workday is a lot of talking with customers and working with hardware developers to make sure that all of our ongoing projects are on track and planning out new ones that are coming in the future. A degree in engineering is very helpful, and the biggest thing is knowing really how to make decisions in a timely manner and take all data that you've gathered and make a decision and move out on it.
No man is an island unto himself. That's one of the things that I've found out in working with the government. You're never alone, and we're very team-oriented. We work in integrated product teams all the time where we're working with program managers, equipment specialists, software developers, even contractors. The critical thing about working as a team is that we're communicating and making sure that not only that our individual goals and individual assignments are being accomplished, but also that the greater goal of the system acquisition is being done.
What I enjoy most about my job is that I really get to make a difference to the warfighter, to people who are flying in planes in bad places on a daily basis. That the work we do here, listening to their needs and translating them into changes in our software and what happens in our box, then ends up on a plane that they can then use to come home safe.